Don't worry about Zoom.
I had one thing I wanted to add to that. Chegg is a big no-no.
The slides are
If you're a person who uses Chegg, stop using Chegg immediately and never use it again. If you're one of those unfortunate people who owe your entire position in this institution to Chegg, I would recommend having a plan B.
Oh, I actually want to see.
So, good. We did the MSTAT policy, I'm pretty sure. Did we talk about the course timeline?
No.
Okay,
No.
question?
Next
Yes, third floor, I think it's to the left, yeah. You come out the elevator, you turn that way, and then it's on the left. So it's a right from the elevator and on. For the men's room, anyway. I don't know where the women's washroom is. Anyway, so, continuing on from our discussion last time, are we recording?
Yes.
Perfect.
Star Wars.
So this is what you may expect from this course over the weeks this course will occur. This is a list of the topics that we will be covering. We will start off nice and easy with introduction and the formation of programming expressions. We will then move on to statements. We will then move into structured data types. For those of you who know a little bit more, we're going to be talking about lists and tuples and strings and things of that nature. Then we will talk about functions, abstraction, and recursion. You shall come to love the term recursion with something approximating Stockholm Syndrome. Numerical computation, which is roughly how numbers in the computer work. Testing and exceptions, very useful material. Object-oriented, which is like, pretty important, generally speaking. We're going to then talk about file I/O. We'll have like a miscellaneous week where we will cover miscellaneous things that require object-oriented. Hopefully we'll have time to get to machine learning at the end. I often don't because things run over time because, it is what it is. You can see the placement of the tests according to this graph. I do not yet know I do not yet have dates and times for the tests. This is an ongoing negotiation between myself and the bookings people. But as soon as I know, you'll know. Any questions about that? Yes?
For the tests, for like the first test, are we also tested on like recursion and the functions?
So in general, first test will be on assignments 1 and 2, roughly speaking. This test will be on 3, 4, and 5. This test will be on 6, 7, and 8. Make sense? Cool. Roughly speaking, these assignments correspond to the material that was covered in the previous week. So assignment 1 will cover expressions, assignment 2 will cover statements, etc. Make sense? Question?
For the test dates, are they established yet, or is it?
No. But as soon as I know, you'll know. So, textbook. Oh, question, sorry.
You said that we might not have time for like machine learning at the end, but will the final exam still have it?
No. If we don't cover it, I won't test it on you. That would just be cruel. And despite, any particular kind of reputation I might have for cruelty, I don't like to think of myself as being a cruel person, so I will try to avoid deliberately cruel activities.
Okay.
So, there are weekly readings, recommended but not compulsory. I think they correspond to the second. I haven't updated them for the 3rd edition, which is, apparently you can't get the 2nd in the bookstore anymore, so there you go. But anyway, John V. Gutag's Introduction to Computation and Programming using Python 3rd edition with applications to computational modeling and understanding data. Very good textbook if you like reading. If you're not particularly, hot on the idea of reading, then not necessary to have read. However, reading it will make you a better programmer for sure, and will help in many various non-specific ways. It's like, you can think of reading that book as like raising your base stats. So, you'll need probably to access the Python documentation at python.org at some point during the semester. There's plenty of books on Python, but no book on Python is a sufficient substitute for essentially your desk reference for Python, which is python.org. If you need to know what a function does, that's the place to look it up. Make sense? / bug the TAs about it. Good. So yeah, I think that we're kind of done with this, except for the boilerplate stuff. But I guess since you guys are like, this is your first time, perhaps we should talk about the boilerplate stuff. So, I think I beat plagiarism senseless last time. So, courses with an online element disclaimer. Whenever you're using third-party software, keep in mind that the end-user license agreements of those third-party pieces of software are in application. So basically, if you're using the Piazza forum to ask questions, Piazza has those questions. You surrender ownership of your data, but nobody should be surprised by this at this point. It's like you can surrender your data to Piazza, or you can surrender it to the university by sending me an email. So so the choice is yours. We won't have to worry about online proctoring this semester, hopefully. So expectations of student conduct, you are expected to conduct. It's like the general kind of stuff. Don't be terrible people, try to be nice people whenever possible. And if you have like an interpersonal conflict, try to resolve it in a way that does not result in bloodshed. All those sorts of things. Don't be mean to people, in general. Students with accommodations for various things. So if you're not already aware of this, the university has an entire bureaucratic apparatus, shall we say, for the management of people who need special consideration with respect to assignment deadlines or test writing periods or things of that nature. So if you are one of these sorts of people that feel you would benefit from, being able to write a test in a room just by yourself, for example, that's one of the things that they grant. You can talk to SAS. They'll set up a meeting for you, establish your learning needs, and you can have those needs met in an official capacity. I get like a letter and get told not to ask too many questions and all that kind of thing, and you can have that. So if you weren't aware of that, now you are. If you need such assistance, please seek it. Academic accommodations for religious, indigenous, or spiritual observances. If I happen to put a test on one of your holy days, for instance, you don't have to write it on that day. You can have an accommodation made for that. So, and that's just one example. So, I make absolutely no claims whatsoever with respect to my knowledge of anything, particularly, what days are good days to do things on. So if I put something on a day which isn't a good day, let me know, we'll work something out, okay? Normally we can just work it out without having to resort to the bureaucratic apparatus, but if you feel it's necessary to resort to the bureaucratic apparatus, that's also an option. I generally find that the less you have to do with the bureaucratic apparatus, the happier you are. It's like directly inversely correlated. Copyright and recording, whatever, extreme circumstances. So in the hopefully unlikely event of something approximating nuclear holocaust and all of us being forced into underground bunkers for a period of some years until the fallout dies down in a somewhat Fallout-like sense, referencing the video game, insofar as it is considered useful by human civilization to maintain the pretense of university while such a thing is going on, the lectures will be online, presuming the internet still exists, et cetera, et cetera. Any questions about any of that? Okay, you want to learn some stuff now?
Yes. Please.
Okay, cool. I apologize for going through that in such detail. It's, it's your first time, so gotta make sure I've dotted all the I's and crossed all the T's. So, that's not me, but the guy who wrote the slides. Yes? They are already. And if they're not, somebody send me an email.
They are.
So,
They are.
thank you. Topic 1, on program. So, what is a program? Anybody have any ideas? You, sir. A set of instructions that make the computer do something. Yes. Although, a program doesn't necessarily have to do something. It can just be a set of instructions that are executed for its own sake, right? Generally speaking, it's a series of computer instructions encoded in a computer language designed to be executed by a computer, sort of regardless as to whether it does anything or not. See, that mixes in too much of an element of subjective human decision about what is or isn't something that you do, right? Or is worth doing. Many mobile games aren't worth doing, but people do them anyway. I'm looking at you, Merge Dragons. So, in general, programs solve mathematical problems. The language of the computer is that of mathematics. Human languages, in the field we call them natural languages. Computers don't really have a concept of knowing or semantics. Anytime, there's been this trend recently of computer programs pretending to be humans and things. Like this, what was that? Was it Google made some AI that claimed to be sentient or something like that?
Oh, yeah.
Those are some big britches for an autocomplete. Basically, anything approximating human intelligence in a computer is primarily statistical trickery. Predicting the next word in a statement, the next word in a sentence based on the probability and examination of a large set of words, things like that. A computer does not actually know what a word means in the same way that a human being does. Computers do, however, know mathematics. They understand very clearly what addition and subtraction mean, because it is programmed into the very circuitry that compose the computer. So, when we write a computer program, we do not write a sentence. This is one of the manners in which I think Python is, a slightly less superior language to learn at first, because a lot of the time what Python is doing is it's loading English words with mathematical operations. Unless you understand that, the word for in Python corresponds to a mathematical operation and not like some semantic dictionary definition, because a computer can't know what a dictionary is or what it contains. You will not really understand programming, right? Everything is math, everything is operations, right? So, good. That's good insofar as it goes. So, what is the square root of 25? What is the square root of some number y? Some number such that x times x is equal to y. That's the definition. That's a definition of square root. Often, a definition of something is sufficient to be able to create an algorithm which calculates it, right? Later on in this course, we will be able to calculate approximate square roots. We'll devise an algorithm for calculating square roots. Do you guys know how square roots are calculated by computers most of the time? Anybody take a guess? When it's being calculated, yes, but most of the time it's simply being looked up, right? Like when you hit the square root button on your calculator, it's looking up the answer, right? A lot of the time. So, sometimes the algorithm is sufficiently inefficient that you want to store results ahead of time for lookup. This is a process known as caching, and we'll see examples of it later on in the course. So, but speaking about more general algorithmic forms, let's consider a problem. Let's imagine we have a function f which is monotonically increasing on some interval ab. Monotonically increasing means that every point further to the left is lower than any point further to the right on that interval, right? And that's true for all points there. So, the x-intercept of a function f is some x such that f of x is equal to 0. In this case, right there. So, it can sometimes be tricky to calculate these things. The following is an algorithm for calculating the x-intercept within a certain interval. The interval that we are, or the precision that we are shooting for with this algorithm, is encoded in the Greek letter epsilon. So we have, generally epsilon stands for error some of the time anyway. So we are trying to find the x-intercept within some certain error, margin of error greater than 0. With me so far? Good. So, step 1. So long as b minus a, that is to say, the size of the interval, is greater than the epsilon that we are trying to get things inside, we do steps 2 to 4. Right? The first of these steps, sub-steps, calculate the midpoint m, which is equal to a plus b divided by 2. So we calculate the midpoint of this interval. Next step, we judge to see whether the function at this point m is above or below the x-axis. If this point is above the x-axis, and we know that this function is monotonically increasing, we know that the intersect cannot occur on this section of the function. So it must occur on this section of the function. Therefore, we move this bound b up to m. Does that make sense? By so doing, we have halved the size of the interval. We repeat this process of halving the interval size until such time as the interval size is less than the epsilon that we are looking for. Does that make sense? Good. Do you want to see a Python implementation of it? This is I don't want to scare you guys with it because it's like this implementation will use stuff that we haven't covered in class, and I don't mean this to be everything I put on the board are things that you should already know. I'm going to teach you how to make this, but it's good to see what the code looks like. Yes, question?
Is this the algorithm we're going to use to solve for the square root?
It's very close to it.
Okay.
Yeah. This is representative of a general class of algorithms called bisection methods.
Mm-hmm.
There's a very famous searching algorithm for searching for individual elements of linear data structures called binary search, which operates on pretty much this principle. So yeah, we're going to be talking about it a bit, but this isn't a course about this algorithm, right? Despite the fact that it is the first algorithm that we have seen. So, terminal. This is Linux, by the way. See? Linux.
Is your computer pink, please?
By the end of this degree program, you too will be able to do this.
I'm just concerned about
Don't be intimidated by command line interfaces. They are more efficient. All right, so. This is an editing program. This is the name of the file that I'm creating. .py is the file extension for Python source code files.
What did you say was the first part? What was the first part?
editing program?
No, I was wondering, what's the first part again?
Get it?
Yeah.
This is get it. It's GNU edit. It's
Python editor.
it's very similar to like Notepad in Windows.
Or you can use VS Code.
That.
Sorry.
Okay, maybe not. It's a little dark. I don't know. Would you prefer it with the lights off?
Yes.
Yeah. Okay, we'll just have spooky mode. There we go.
I should.
All right. So, can I turn my keyboard backlight on?
I feel like I'm in a movie theater.
Good. I'll try to hold off on the drama though. So, def intersect. All right? Takes some function f, some interval a, b, and some epsilon x. Right? So this is what's known as a function declaration. Right? F, a, b, and x are the inputs to the function. We will operate on them to produce some output. So, what is our algorithm? So, our condition is, so long as b minus a is greater than epsilon, we do other steps. This corresponds in programming code to something called a loop. Question at the back.
I'm a little confused as to what epsilon means in this scenario.
Sorry, can you speak up?
I'm a little confused as to what epsilon means in this scenario.
It's the margin of error, right? It's properly understood as the stopping point. Because our interval continues to narrow as we process the algorithm, right? Once it gets smaller than some specified epsilon, we will stop. If we didn't have that, the thing would literally just continue forever. Make sense? Okay. So, while b minus a is greater than epsilon, we do stuff. First thing we do, calculate m is equal to a plus b divided by 2. Next, conditionally, if f at m is greater than 0, we set a to m. Otherwise, we set b to m. So, if f at m is less than, let's say less than or equal to 0, then a is equal to m. Otherwise, b is equal to m. That will continue until such time as the interval AB has been divided enough times to be smaller than the epsilon we're looking for, at which point that loop will finish. Once the loop finishes, we return the result that we want, which perhaps is the interval itself, the new interval. We could also return the midpoint or something like that, but this will do for now. So, fine. Let's define a function for this to operate over. So let's say parabola, taking some input x, returns something like x squared minus 4. Should be fine. So, these are programs. Defining a function does not run a function. In order to actually run these programs, we need to provide them with concrete inputs, right? In other words, we need to operate over actual numbers, right? So let's provide it some actual numbers. Function invocation. We shall print the results of calculating the intersect of the function parabola given a starting point of, let's say, 0.2, an end point of, let's say, 50, with an epsilon of 0.00001. Well, maybe not quite so many zeros. All right, save that. So, because I'm doing this in terminal, I have to run this from terminal. You guys have the added benefit of being able to just press, press play on a box inside of Jupyter Notebooks, right? But for this, because I'm doing this in the operating system, I actually have to invoke the compiler or the interpreter as it is. So the way that you run a Python source code file, in Linux at least, Python 3, topic1.py.
Did you say that?
So there you go. If you will have noticed, the manner in which I set up this parabola, x squared minus 4 should put the x-intersect at precisely 2. You'll notice that the output result of this program is an interval from 1.99999, etc., to 2.00000, etc. If you measure, if you compare these numbers to the epsilon, you will notice that the difference between these two numbers is less than epsilon. So, it's fine to have the computer just, throw a number at you. You can also ask it to, display intermediate information. So, for example, let me just set this up quickly. Going to print some braces, print string convert A. Again, you don't have to know how to do this yet, but you will eventually. String convert B, there we go, etc., etc. Run it again, and there you can see all of the intermediate steps. So you can see we start with 0.2 and 50. In the first step, we draw 50 down to 25.1, which is the midpoint between 0.2 and 50. And we keep dividing that on and on and on it goes until such time as we reach the interval from 0.2 to 3.3125, in which case we start moving the other one up. And you can see it sort of jumps back and forth between the two until it approximates the value of 2. So this is a numerical method for finding the x-intercept, not an algorithmic one. It does it by testing actual numbers. I'm going to open the lights back up so I can see if anybody has any questions. Any questions? At back?
Where's the value that x is getting from the parabola?
Where is the value that x is getting from the parabola? Well, you see, that's actually a fairly interesting. It's a little bit complicated. So the question in general is like, how is this parabola function getting values, right? Right in this step here, right, we calculate m from a and b, which have concrete values, so m is also a concrete value. When that line happens, we step into the function specified by f. F has been provided the value of the function parabola. So here, f becomes parabola. There, it's given the value of m. That's how it's being calculated. Does that make sense?
That's not quite what I meant.
Oh, okay.
And then how, where is, okay, parabola taking in variable x, correct?
Yes.
Where is x coming from?
It's local to the function. So it does not exist outside of the function. It's a name that only exists so long as the function exists. But values will be assigned to x when the function is called.
Yes, but where is the value being assigned?
Again, it's implicit in the function call itself. That's where, so when a function is called, right, like here, actually, let's talk about this one because this might be a little easier to understand. So this is an invocation of the function intercept, right? We provide a value of 0.2 in place of parameter a, right? So when we call this function, 0.2 is assigned to a in the process of the function call. So once the function executes, it executes with the value 0.2 rather than some symbolic value of a, right? Does that make sense? Question?
I think he's trying to say where, like, the parabola, like, where is x coming from, which I think it's m that's calculated in the intersect function.
Yes. Yeah.
I think that's what he was asking. I'm not
Okay.
sure.
At any rate, we should probably keep going with the slides. So, good. Just be warned, there's going to be some slides that I skip because I generally prefer to do coding demonstrations in class rather than doing a bunch of like this. I skip some of the slides so I can give you guys more examples. I hope that that's like useful. Anyway, so good. So we now have seen a program. Let's talk about some of the properties of programs. Programming languages basically come in two main flavors. You've got declaratively described languages and imperatively described languages. Can anybody hazard a guess whether Python is declarative or imperative? I know you know what you're talking about, so let me see if somebody else is. Yes, sir.
Imperative.
It is imperative, yes. So, you guys familiar with Harry Potter?
Yes.
Yeah. You guys know what the 3 unforgivable curses are? What are they? Yes, sir.
Imperio, Crucio, and Avada Kedavra.
Right. So Imperio, right? What's it do? Anybody else? Yeah?
Controls the user that they use it on.
Yes. It is a mind control spell. right? Or a control, it's a puppeteering spell. But J.K. Rowling, bless her heart, basically picked most spell names from Latin. So the Latinate root of the Imperio spell is the same as imperative description. You are giving commands in imperative languages, right? In declarative languages, you are describing properties. It's the difference between telling the computer what to do and how to do it. If you're programming in an imperative language, you are telling the computer how to do it. If you're declarative, you're telling it what to do and hoping that its own automatic algorithms can figure out how to do it. Does that make sense? Examples of imperative language. All C-based languages, all object-oriented languages. Examples of declarative languages. How many of you are taking 1JC3 right now? Yeah. Have they talked about Haskell yet?
Yes.
Yeah. Declarative language. So, generally speaking, when you're programming with an imperative language, everything fundamentally that you write is either a direct command to the CPU or something that stands in for direct commands to the CPU in a more direct fashion, right? In a language like Haskell, what you're doing is you're kind of setting up functions and working in a more abstract, beautiful language of the universe kind of way. Yes. So, let's talk about algorithms now. An algorithm specifies a sequence of instructions to be executed by a machine that will produce an input, or that will take an input and will hopefully eventually stop and produce some output. Not all algorithms terminate. It is absolutely possible to write an algorithm that will run literally until the sun engulfs the earth. Very simple. In fact, you can write it in like 2 lines. You want to see it?
Hello World.
No.
Huh?
You make a loop, and then you.
Yeah, okay.
And then
I'll even throw in a print statement for you.
you make a boolean that's true, and then you write a loop, and then you put the boolean in the.
Well, you could just do
thing.
while true.
Yeah.
That works too. Sorry.
So, it's very simple. While true, pass.
That's horrifying.
It's horrifying. So,
Don't run it.
there are, I know it's like really hard to see, there are actually useful applications of loops that are non-terminating. You see them come up in some particular domains like embedded systems. Fundamentally, your operating system is a loop that doesn't terminate until you send a shutdown signal, right? So there's more than one way to terminate a loop than just than modifying its conditional. But that program, while true, will do nothing forever.
Nothing.
Literally, it'll do nothing until the computer breaks. So, algorithms can be thought of in the same way as you might think about a recipe for cooking delicious food. When you cook, you are taking inputs in the forms of ingredients. You are following a procedure in the form of a recipe card or a book, and you are producing outputs which are hopefully edible. Traffic intersections are also a typical example. Inputs, timing signals, outputs, electrical signals to light bulbs, instructions, the sequence in which these lights need to be lighted. In order for civilization to exist, these things have to be operational. So it's very important that the algorithms are, it doesn't have to be complicated to be an algorithm, right? They can be very simple and still be extremely important. But anyway, so, computation prescribed by an algorithm goes through a sequence of states. starting from an initial state, and each instruction leading to a new state. The concept of state is extremely, extremely important in computing. State basically means the values currently held in the variables of the program. The concept of a variable in computing is very different from the concept of a variable in algebra, which you might be used to. In algebra, a variable may have many different values, and it is your object as the mathematician to isolate the particular value that a variable may have, if it is possible to do so. In computation, a variable is simply memory. It is a named segment of memory. So, because the ones and zeros that make up the computer itself, the electrical signals, can only be in either a high or a low state, they can only be a 1 or a 0, there is no such thing as a piece of memory that does not contain a value. All variables have concrete values all the time. Now, whether that concrete value is meaningful or not, that depends on a great deal, right? But in programming, every variable in a program, I'm almost done, every variable in a program has, at any point in time, a specific concrete value, and the collection of all of these concrete values in a program at a particular point in time is the state of the program at that point in time. In order to understand the operation of an algorithm, you need to be able to view the intermediate states of the program. That's what I did in my example when I showed what A and B are as they change as the program executes. This is known as a trace. Okay? Any questions? Okay, get out. Oh, question?